In 2019, an outbreak of the novel coronavirus, or COVID-19, occurred in the province of Wuhan, China. This emergent illness had its origins shrouded in mysterious rumors. It soon began to rapidly spread and became a global pandemic in early 2020. Many cities had issued public health orders that required all persons within city limits and in public to wear protective face covers. Persons exposed to the public should be wearing a cloth mask that covers the nose and mouth. These orders were in attempts to prevent the spread of the virus rather than protect the wearer from becoming infected. In response to this crisis, our team of biomedical engineers was called to develop a method in which to stop the spread of this deadly virus. After studying the virus and how it transmits, we aimed to not only prevent COVID-19 from spreading, but to make humans immune to the virus.
We found the most effective face covering to be made from high-efficiency particulate air or HEPA vacuum bag filters. This filters air through 4 different mechanisms: diffusion, interception, inertial impaction, and electrostatic attractions. HEPA filters 99.97% of air particulates at 0.3 microns that they come into contact with. We used our biotransport phenomena knowledge to genetically engineer a human who's immune to COVID-19. Modeling after filtering properties of HEPA filters, we developed a biocompatible HEPA filter-like skin graft to be integrated into our test subject's skin. Within a few hours, the skin had miraculously grown to form a protective layer covering the entire body of the test subject. The skin had begun to overgrow to form thin coverings over each of the orifices of the body. These newly formed orifice coverings were able to extend and retract as the subject controlled them. Being that the protective skin layer acted much like a HEPA filter, our test subject was still able to breathe properly even if the thin coverings were extended. This special suit will result in no mass transfer in the X directions, where transport in the Y and Z directions is negligible. Using a microscopic transport approach with rectangular coordinates, this can be modeled as the following equation, where P is equal to the concentration of the virus particles in the environment air. The mechanism allowing the protective skin layer to prevent mass transport of the virus through the skin is the diffusion of air and particles through the outer and inner layers of skin while inhaling and exhaling. This diffusion can be modeled by Fick's law of diffusion. The protection factor can model the effectiveness of reducing mass transfer of the virus from the outside of the skin to the inside. The protection factor of the protective skin layer can be determined by the following equation, where C out is concentration of virus particles on the outside of the skin and C in is the concentration of virus particles on the inside of the skin.
Dubbed the incredible Covinator, his only weakness to the devastating virus was the heat through any transfer mechanism of conduction, convection, and radiation. If his skin reached a temperature of over 100 degrees Fahrenheit, his pores would start opening and he became vulnerable to the virus again. To combat convective heat transfer, we used a material with a high chemical potential to support mass flow away from the interface surface. The goal was to reduce the convective heat transfer coefficient as modeled by this equation.
To combat conduction, we the geniuses designed a suit with very low thermal conductivity that would regulate his skin temperature. This suit monitors the outside temperature and if it reaches a temperature of 90 degrees Fahrenheit.
To prevent his skin from reaching high temperatures by radiative means, the suit will be colored white to prevent black body labeling. This will reduce the emissivity black body power in the following. Another super quality Covinator has is his ability to transfer his powers. Through a high five, the HEPA particles in his skin transfer to the other person through an exchange in momentum. Enough force must be applied for this transfer to occur. This is not a problem for the incredible Covinator as he is strong enough to always make it happen. The Navier-Stokes equation can be used to model this momentum transfer. Assuming that the transfer only occurs in the X direction, the incompressible particles are evenly distributed across the hand and flow continuously. The particles can be modeled as a Newtonian fluid, and there is no concentration change in any.
Oh, you poor little helpless civilian. Allow me to transfer my power to you and save you.
Thanks, Covinator. Covinator's powers allow him to travel the world and give people high fives to help spread a preventative measure against this deadly disease.
Look everyone, the Covinator's flying above us!